factor in a number. The need for early detection and alert of wind shear conditions is obvious in the airline industry. The delay of proper response and the lack of wind shear detection was cited as a causal factor in a number of takeoff and landing crashes. The FAA is currently improving the recognition of wind shear conditions by the installation of low-level wind shear alerting systems at various airports. In addition, the FAA determined that an on-board recognition system would be helpful to flight crews. To this end, FAR 121.358 was born. It requires that U.S. commercial aircraft with over 19 passenger seats be equipped with a wind shear detection system. Specifically, FAR 121.358 requires that airlines install an airborne wind shear warning and flight guidance system, an approved airborne detection and avoidance system, or an approved combination of these systems. A microburst is a downdraft that is typically 700 to 3,000 feet across. The velocity of the downdraft is usually between 40 and 110 knots. This airflow mushrooms out as it hits the ground, causing the wind energy to flow in all directions. Approaching the microburst may produce a positive component, usually over 40 knots velocity. In the center, your aircraft experiences the downdraft energy. On the other side of the microburst, your aircraft will experience a tailwind component of 40 knots or more. Now, one common type of onboard recognition system is the reactive wind shear system. A reactive system detects wind shear conditions by monitoring the performance of the aircraft and issues cockpit warnings and flight director guidance after the aircraft is detected to be within a wind shear environment. Although a reactive system is helpful by providing detection and guidance, it does nothing to prevent the entrance into the wind shear. After the crash of the DC-9 in North Carolina that was equipped with a reactive wind shear detection and guidance system, the need for prediction and early warning of wind shear conditions was apparent. A predictive wind shear detection system, or PWS, provides detection of wind shear in front of the aircraft during the takeoff and landing phases of flight. The predictive wind shear system operates automatically and is transparent to the flight crew unless a wind shear event occurs. Now, some aircraft have a reactive system, others have a predictive system, and some aircraft have both types installed. This frame provides an overview of the features of reactive and predictive systems. The reactive system provides detection alert when the aircraft flies through wind shear conditions and then provides flight director guidance to optimize the recovery maneuver. The forward-looking predictive system provides detection alerts before entering the wind shear condition. The alerts are provided as advisories, cautions, or warnings. Thus, a pilot has the information necessary to avoid dangerous weather before it's encountered. If a wind shear is unintentionally encountered, the flight crew will use the standard wind shear recovery procedure as listed in the flight manual. How does a predictive system operate? Well, recall that the weather radar emits short, intense pulses of microwave energy which are returned by reflection. The reflected signals are received and processed to determine the intensity, bearing, and distance to the targets. This system provides reliable return for water droplets, water-covered hail, and terrain mapping. The weather radar has an advanced microprocessor design which allows it to use the Doppler concept to detect areas of moderate and high-level turbulence as well as low-level wind shear, or microburst. The top aircraft is above 2300 AGL, and you can see the weather radar sweep. The bottom aircraft is below 2300 AGL, where the PWS automatically operates. If the weather radar is on, each radar sweep alternates between a weather sweep and a wind shear sweep. This alternate scan may delay the update of your weather display by up to 12 seconds. The pilot selected tilt is operative during the weather radar portion of the sweep. However, automatic tilt is applied during the wind shear detection portion of the sweep. The detection of wind shear conditions is accomplished by detecting the Doppler shift of the horizontal wind component. The detection system is able to detect the velocity of droplets coming at your aircraft and compares this to the velocity of droplets moving away from your aircraft. The velocity level of these approaching and departing droplets determines the level of alert. It's assumed that the horizontal speed of the droplets is a direct indication of the intensity of the downdraft. For the PWS to operate, you must have the PWS switch in auto, be at an altitude below 2300 AGL, and the transponder must be selected to on or auto with either engine running. Now note, although the PWS is operational below 2300 AGL, no advisories are provided to the crew above 1500 AGL or between 0 AGL and 50 AGL. The PWS scans the airspace within a range of 5 nautical miles in front of the aircraft for wind shears. When a wind shear is detected, depending on the selected ND range, a warning, caution, or advisory message and a wind shear icon appear on the ND. The warnings and cautions are always accompanied by an oral alert. The weather returns and wind shear icon display on the ND. In addition, a wind shear ahead annunciation appears on the PFD in amber for a wind shear caution or red for a wind shear warning. Let's describe the 3 levels of wind shear detection alert that are provided for takeoff and landing. The lowest alert level is the wind shear advisory. It's delivered by a display of the wind shear icon. The icon displays the wind shear location relative to your aircraft. This mode is available when below 1500 AGL. It's delivered when a wind shear is detected within 5 miles ahead and within plus or minus 40 degrees of your heading. The next alert level is the wind shear caution. It's delivered by the icon display, amber wind shear ahead message on the PFD, and an oral warning of monitor radar display. This mode is available when below 1200 AGL. It's delivered when wind shear is detected within 3 miles ahead and within plus or minus 25 degrees of your heading. Now the highest alert level is the wind shear warning. It's delivered by the icon display, a red wind shear ahead message on the PFD, and specific oral warnings of wind shear ahead or go around, wind shear ahead. Wind shear warnings are available when below 1200 AGL. A warning is delivered when wind shear is detected within 3 miles ahead if you're on the ground and 1.5 miles ahead if you're airborne. A wind shear warning indicates a wind shear is within 1/4 nautical mile laterally either side of your heading. All PWS alerts are inhibited below 50 feet AGL. In addition, the visual and oral warning alerts are downgraded to caution alerts between 370 AGL and 50 AGL and range between 0.5 of a nautical mile and 1.5 nautical miles. Specific company policies are in effect for crew response to a PWS advisory. These policies govern operation prior to takeoff, during takeoff and climb out, and during approach. A predictive wind shear off memo appears when the PWS is selected off. The memo is green in flight phases 1, 2, 6, and 10, and amber in phases 3, 4, 5, 7, 8, and 9. You should know that the PWS alerts have priority over EGPWS and TCAS alerts. For safety purposes, ground personnel should remain beyond the red area shown here to avoid the U.S. government standard radiation level of 10 milliwatts per square centimeter. The maximum permissible exposure level boundary is approximately 13.4 feet from the radar antenna center at approximately a 240-degree arc. Recall that microwave energy is also transmitted when the weather radar is turned on. Pilots must ensure that both the weather radar, the transponder, and PWS be turned to the off or standby position before approaching the gate area. Well, now, let's answer some questions.